know much. I don't know what to say about the Big Crunch. I don't know if that's a thing. Shall we? So I know I've talked a lot about quantum mechanics and relativity. Let's talk about Kepler's laws. Oh, I was just asking how you feel about the empty space outside of our universe. I don't know. That's so I am answering seriously as well. I don't know about the empty. I don't know what that is. I only know about the universe. I don't know about what is outside of the universe. Not to my knowledge. Let us now talk about Kepler's laws. Because I feel like I have neglected classical mechanics on this channel. I've talked about quantum, relativity, all sorts of things, but I haven't really talked too much about classical mechanics and planetary motion. Look up Mike Markham. Interesting. He was an electrical engineer that constructed a Jacob's ladder. Okay. All right. Kepler's first law. Yay! Kepler. Planets travel on elliptical orbits with the sun at one focus. The properties of the closed curve known as an ellipse are best described by explaining how to draw one. Take a piece of string and tie each end to a pin. Stick the pins into a piece of paper, separated by a distance less than the string's length. Use a pencil to stretch the string taut and draw a complete closed curve. This is an ellipse. Yay! The two pins are located at the foci of the ellipse. Expressed mathematically, the ellipse is the locus of points for which the sum of the distances to the foci is a constant, equal to the length of the string in our graphic example, which we'll show here. See? That's an ellipse. So, if the pins are moved closer together for a given length of string, the ellipse becomes more nearly circular. If they're moved farther apart, the ellipse becomes more flattened. The longest distance across the ellipse, which passes through both foci, is called the major axis. The shortest distance across the ellipse, passing through the ellipse's center, is called the minor axis. The semi-major axis is half the major axis, and the semi-minor axis is half the minor axis. The eccentricity of the ellipse is the distance between the foci divided by the length of the major axis. If the foci coincide, then E is equal to 0, that is the eccentricity, and the ellipse is a circle. The other limiting case, E equals 1, represents the case in which the foci are separated by the full length of the string. It was quite a feat for Kepler to discover the elliptical shape of planetary orbits, since most planets have orbits with small eccentricity. Of the planets known to Kepler, Mercury had the largest eccentricity of E equals 0.21. All the others had E less than 0.1. Yes! Johannes Kepler. Wow. So that was the first law. Let's say the first law again. Planets travel on elliptical orbits with the sun at one focus. That's the first law, and then we talked about what an ellipse is. So, done with that first law. Second law! Kepler's second law. Aww. My little cat.